Okay.
Started just now or like record the
So
last
explain
like
it
30
again.
No, I started just now.
Oh,
Okay,
okay, okay.
explaining it again. Let's say this is our scatter plot. Pretend you guys don't know what I just said. Um, call this point here about 10. This is your observed value, so this will be your actual value. This is your equation of the line, so let's predict a value at 1. It's going to be about 8. This is your predicted value. And this point at 1 is about 10. And your residual is your actual minus predicted. So 10 minus 8, your residual here is going to be about 2. Okay, there you go. Question 1 done. Wait, Ian, were you going to say something?
Nothing.
Okay. Given a scenario and or scatter plot, be able to determine the explanatory variables versus response variable. Explanatory is the x and response is the y. I don't know what else to say about that. Response. That's it. That's all there is to the second part. Know your correlation properties. Recognizing a correlation does not have a unit value. So let's say your context, you're measuring height from age, like I kept saying. If your correlation is 0.89, it's not going to be 0.89 inches. That's not true. It never has a value. It's just 0.89. That is the value for correlation. There are no units. The correlation can be both positive and negative. Correlation determines slope, so when it is negative, the slope is going to be downwards, and when it's not negative, it's going to go up. Correlation will never be lower. Yeah, correlation, oops. How do I go forward? Correlation is -1 to 1.
Everyone and their mama is streaming. What we streaming?
We're streaming
Why are
back.
you on Valorant?
Get off Valorant. Okay. Recognize that correlation, any correlation that digits are the same, but one is positive and one is negative, all are equal in strength, and correlation does not imply causation. I'm not gonna.
You start, really close to the mic.
Understand what correlation means in context. Okay, correlation, the interpretation is LSD. The relationship, this is how you do your context. The relationship between, I can't spell, between X and Y is linear,
To right.
like moderately strong. No, I just bought a drawing tablet today for this.
Aggressive is aggressive.
Moderately strong and positive or negative, depends on what your correlation is. Must know that every least square
LSD,
regression
not
line.
the drug.
Yeah,
It's a
not the drug.
Oh.
Okay.
I love LSD.
Guys,
Nick,
this
I
is
have a
getting
question.
uploaded. Yeah?
That's
Okay.
How do
okay.
you how do you know the strength of it based on R like how do you know if it's moderate, strong, weak?
There's no way of really telling. I say from point 0.8 to 1, it's strong. From like 0.6 to point 0.8, it's moderately strong. And then like from point 0.4 to point 0.6, I'll say it's like somewhat strong. And then anything below we'll say relatively weak. That's kind of what I say.
That's
As
valid.
you screwed over my team.
Below is relatively weak. Okay. That makes sense for everyone?
Okay, thank you.
Okay, cool.
Yes.
My Paint 3D just froze.
Okay.
Must know that every least square regression line passes through the mean of x and y. Yeah, that's true, and that's kind of the logic that you use to find the equations of the lines when you're given like y hat, x hat, all that stuff. And that's how the Minitab outputs are calculated. Given an equation or Minitab output, determine the estimated slope and what it implies. I think I have a Minitab output like Google search somewhere. If not, I'll just pull one up.
Will you send my dinner, Ian?
Yeah.
Okay.
Good.
Love the quality. Let me put it like right there. Okay. What was I asking? Slope. Okay. Slope is whatever the named variable is. And by the way, this is your x variable, if you're
Why are you in
curious.
the dark?
So your slope is going to be 0.55528. And it looks like it's predicting exam score. So for every It's predicting exam score from revision time. So for every one unit increase, I don't know if it's minutes or something, so I'm just gonna say 1 unit increase in revision time, there's an expected 0.55528 point increase. I'm assuming that's how they measure exams in exam score. That's how you're gonna interpret slope. And then slope, correlation, y-intercept. Correlation, I think that's a 7. I can't really tell, but we'll call it a 7. So r squared equals 0.728.
Sorry.
And then r equals square root of 0.728. So whatever that is your correlation. And then y-intercept, I'm gonna do this in order. Y-intercept, that's when x equals 0. So when there was no revision time or 0 revision time, there is an expected, let me underline expected, exam score of, what's the y-intercept? 44.54.
Is
Okay.
everybody paying attention?
Yeah, yeah, totally.
Yes.
Okay, cool. Who has their camera on?
Me. This is my dinner. There was strawberries, but I finished it all.
Okay.
Mm.
What else does it say? Coefficient of determination, r squared. I already talked about this, but r squared is variation in y explained by x. So in this case, your y is exam score, x is revision time. So we'll say 72.8% of variation in exam scores can be explained by the line using
My bad, guys.
revision time
Um,
to predict exam scores. That's your coefficient of determination. I should probably just be typing this because my handwriting on here is really bad.
I was gonna say that.
Any predictions based on that LSRL? Okay, yeah, I think you guys get that. And yeah, when I'm doing interpretations, I'll start typing from now on. I think that's all there is to do on a mini tab.
You
Okay,
should pop quiz them.
not in the middle of the notes,
See if
bro.
Oh, I forgot.
If I get an upload error, I'm gonna cry. But understand that the idea that least squares. Okay, so what this one is saying is like if this is your line, blah blah blah. This line is calculated because the area of each point from the line is as small as any line could possibly be. So like if you added all these up, like the area of all these, it'll be as small as possible with this given data set. That's all that means. That's why it's called least square regression line. What next? Given a residual plot, determine if a linear model is appropriate. Guys, is this appropriate for a linear model?
No, it's too pretty.
Yeah, it's too
yeah,
curvy.
No.
Ian, shut
There's
up.
a pattern.
Yeah, there is a pattern in this. You don't have to name the pattern. Don't call it parabolic or anything. But if there's like a pattern, so like even if it's like this, then you still know it's
Just
not
say there's a
appropriate.
pattern.
You
Yeah.
can't use the line to predict why.
Yeah. So is this appropriate?
Wait, we don't have to.
That's what I like to see.
Exactly. Good job. That's appropriate. Gavin, what were you saying?
Wait, I have a. We don't have to explain like what do we see. Like we just say, oh, there is a pattern. It's not
No,
appropriate.
you just have to say the pattern shown in the residual plot suggests that a linear model is not appropriate.
Okay.
But if it's scattered, you can say like the scattered pattern suggests that a linear model is appropriate. But you don't have to name like if it's like this, you don't have to say what this will be like.
Don't say scattered pattern. Just say the residual plot is scattered.
Yeah.
Don't call it a pattern.
True. Okay.
Okay.
Given a computer output, determine the coefficient of the. Wait, we just did that. Wait, Okay, given a
Are you
scatter
going
plot.
backwards?
No, I'm not. Be able to determine the relationship between two variables. R equals. We'll say that's like 0.87. We'll say this is pretty strong. So strong.
Hello.
Wait, let me go back to my example. Age and height.
It's metal.
Okay, let me type this one out this time.
Hmm.
The relationship between age and height is strong, linear. Wait, let me do this in the order you're taught. Is linear, strong, and positive. LSD. Okay. I think we're good on that one. Everyone knows how to do that. Oops. Bro. Okay, whatever. Next, determine the effect of one point on the line. If I added this point, what would it do to the slope and y-intercept? And yeah, wait, I said slope and y-intercept.
Can I answer?
Does anyone else want to answer first?
It will weaken the correlation.
Yeah?
It will bring the slope down,
Yeah?
and
Yeah.
With y-intercept.
It'll what the y-intercept?
oh, it will increase the y-intercept.
Yeah. Because to
Yo.
fit the line better?
Yay.
Oh, that's not good. It'll probably end up being like that. So yeah, all those things are true.
Yay! Yay!
Let's see. Given a scatter plot that shows comment on the relationship, meaning if I have a scatter plot that is referring to your hand span on the x-axis, I should probably pull this up on the screen. We're on number 13, guys.
It's a little.
Oh, sorry. um, comment on the relationship referring to your hand span on the x-axis. Both male and female on the scatter plot representing males. Comment on the relationship between the two genders. Okay, so let's say this is age and height in men, and then this is age and height
Age and height.
in women. But then let me add like. Would you say there's more of a correlation between the age and height in men or in women?
Men.
Oh, sure.
Yeah, true.
Why?
Oh, man.
Yeah, why?
Explain it, Gavin.
There seems to be a higher correlation between
Like
But why?
point.
Oh, really?
the dots seem to be on the line better.
The data seems.
also-
Yeah, okay.
Okay. Okay.
Just please use better vocabulary when you answer that.
Oh,
But
yes.
yeah,
I'm
you have the right
sorry.
idea. Okay, 14. Given the correlation coefficient, the mean and x of y. Oh, this is my favorite question. We've gone over. This is the third time I'm going over this tonight.
Oh my god.
Okay, someone other than Gavin, give me numbers.
3,
Another one.
7.
Okay, another one.
4,
Okay, another one.
620.
Shut up, bro. Someone give me a normal number.
Hey!
Okay, I'm
9.
saying okay, 9, good. And we'll say correlation is like 0.87.
You like
Okay.
that number, don't you?
Yeah, it's yeah. Okay, what's the wait. Let me do it right this time. A equals. What's the formula for slope with this type of data? Does anyone
Y
remember?
equals A plus BX.
That's
or-
the formula for the
yeah, I'm
regression
tripping.
line, not for slope.
Oh.
Slope specifically right
Oh,
now.
wait. Oh,
Oh.
like to find the
To find
equation,
slope, yeah.
wouldn't it be the standard deviation of Y over standard deviation of X
Yeah,
times
but
the correlation?
yeah, exactly. So plug those numbers in times 4 over 9. And whatever this is equals your slope. What does this equal?
That
Someone
would
tell
be
me.
B, right?
Um,
Oh, that's A? Oh, I got that.
oh, wait, no. You're so right. It is B. But it doesn't matter which one's which. On the formula sheet, they say slope is B. But you can use either one. As long as you recognize which is which. What variable you use doesn't really matter.
Oh, okay.
So, did anyone do the math? Anyone have a calculator?
I did.
Okay, what is it?
I
Sure,
said I did
watch
not.
it.
Oh, okay.
You put like 5.
No, I'll actually do it. 0.87 times 4 over 9.
Interesting number.
Okay, 0.386. So your slope is 0.386. And from here, if anyone in here is in calc, you can use a point slope form like you would normally. Otherwise, you can plug in the means to find this. So using the equation y equals a plus bx. The mean of y is 7 equals a. We don't know that yet. Plus, we just found 0.386 times the mean of x. 3. So we're plugging in the means to x and y. So we can find a. So 0.386 times 3. 7 equals a plus 1.16, and then just solve algebraically. And then you'll get a equals 7 minus
I'm sorry, guys.
5.84. So your equation is going to end up being y hat, Alvin hat, equals 5.84 plus 0.386 x. That's how you do that.
Don't forget your hats.
Don't forget your hats. Any other questions on
this
this?
heat.
Should I explain anything else on here? Do I need to go back over anything?
Wait,
Okay.
so
Yeah.
Y'all could at least say no. Yeah.
Ian, what were you saying?
okay, you can delete it now.
Okay. Be able to find what percentage of variation in y is accounted for based on x given the LSRL. What variable tells you that, guys?
Variable.
What?
Can you repeat that?
Variation in y explained by x given the LSRL.
Oh, that's the coefficient of determination? Like
Yeah.
R squared or?
Yeah.
Okay.
Yes.
Okay, you guys got it.
Wait, make one of them interpret it.
Okay, guys, if your r squared equals 0.838 and then x equals age, y equals height, what's your interpretation going to be?
I have an answer. I have an answer.
Yeah,
Okay.
Gavin.
Oh,
Go ahead,
Me,
Gavin.
I have an answer. Okay, 0.838. About 83.8% of in variation of height is explained by the linear model given age, given x equals age.
Height is explained by the linear model given age. Yeah, this is mostly right. I
Did
think
I
you'd
forget
still
to put
get.
about at the beginning?
Don't you say
No, no,
like
no, no, no.
typical or
You'll say you'll say
or
like
average?
about or typically. No, not for this
On
one. You'll say
average.
about, I think.
yeah,
This isn't
they
standardized.
want
This isn't
about
standard.
because yeah.
About 83.8% of variation of height is explained by the linear model. I think give more context using age to predict
To
height.
predict? Oh.
Yeah,
Oh, to
this
predict
is
height. Oh,
this is
okay,
the
okay.
perfect interpretation. So yeah, this is probably what you want to memorize. About blah 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 variation in y is explained by the linear model using x to predict y.
Using x to predict. Okay.
Yeah. Okay, next question. Looking at scatter plots or data or Minitab output, determine what type of transformation was used to linearize a set of data. Okay, guys. What model was used here?
It starts with a E. No, it starts with E. No.
E.
Exponential model.
Yeah, exponential model. And then
E.
how about now?
Power model.
Yeah, there you go. Oh, let me switch back to this one. Power. Okay. Write the equation for an LSRL of transform data given Minitab output. I already did that like a lot, but I'll do it again. Let me pull up the example I used. Here, this is the one you use. What's the equation?
For exponential or power model? Oh wait.
This is just a Minitab output, no models or anything.
Oh. So 27.54 plus 1.1931x.
Exactly. That's the easy one. And then make predictions for okay, when x equals 13, what is the predicted value? You just plug in 13 for x. I'm sure everyone knows how to do these last couple. Compare transformations of data and determine which model is better. Okay, this one's really easy too.
43.027.
I trust that your math is right. That sounds about right. Okay. This is an exponential model. And then this is a power model. Which one looks more appropriate for a linear model?
Power model.
Yeah.
Yeah. It's just whichever one looks more like it follows a line. This one you can see has some curvature to it. That's how you judge which model is better in that scenario.
Mm.
And then last one, know the difference between transforming data using a power model versus an exponential model. Okay, we did this so many times. What's the difference? If this is exponential, and this is power, what are the axes going to look like?
The log for exponential is only on the y-axis, and the power model is for both.
Exactly. Okay, that was everything on the what you need to know. Okay, I'm gonna stop there. Yeah.
That's
Huh?
everything.
On God?
Yeah.
Oh,
That doesn't seem that hard.
Wait,
that is not
Gavin,
that
is there a
hard.
second page you forgot to show me, or?
No, that's it for Miller.
Okay, I'm ending the recording then.
I think it's basically just like
Wait, how do I do this?
memorization.
Control
Don't forget to
Shift
like,
E.
subscribe, and
Yeah, don't
comment
forget
down
to